Welcome to session 1 of Kubernetes Administration. In this session, we are going to cover a very basic overview of Kubernetes. What is Kubernetes? And we talk about the DevOps, where Kubernetes is a very critical, important tool in DevOps. So what exactly is DevOps? What role your Kubernetes play in the DevOps? Okay. Why we use the Kubernetes? What are the some basic features of Kubernetes? Okay. And then a small basic architecture of the Kubernetes. So let us begin with the DevOps. Okay, so Kubernetes is a DevOps tool. We heard a lot of about that. We use the Kubernetes in DevOps. Okay, so but what exactly is DevOps, and what role does Kubernetes play in it? So DevOps is a collaborative approach that combines development and operations team to automate and streamline software delivery, ensuring faster release and reliable performance. Okay, so now one basic thing is that DevOps is a collaboration, or it is a combination of development and operations. Development means when we do the development of our softwares. Okay, and then operations. Once the development is completed, then we deploy it in production environment. Okay, when it is in operation and maintenance phase, and that is called the operation. Now, between development and operation, there are multiple phases. Okay, if we talk about the standard software development life cycle, okay, the traditional way is we develop the softwares. Okay, and after the development, we do certain kind of a testings, which include the integration testings as well, specifically if you are in an enterprise world where you have a integration with the multiple applications within your organizations, or maybe outside your organizations. Okay, maybe between the cloud and on-premise applications, or there could be multiple integrations in your applications, right? So you, after development, you have to do a lot of testings, which could be a unit testing of a specific module, and then you may have to do a integration testings, okay, to ensure that your software is working properly with all integrations as well. So once that is done, you it has to move to the testing environment, and when it is tested properly, then it goes to the production environment. So there is a long chain of the software development life cycle from the development phase till it goes into the operations, right? Now this DevOps is a technology which automate and streamline software delivery, ensuring faster release and reliable performance. That means DevOps is a area which focus on the automation of complete all of the steps that we have been talk about just some time back. Okay, from development till operations. Okay, so that the delivery of the software from your development till the production environment get faster and with the reliable performance. So this is the all about the DevOps. Okay. So now we have a lot of different set of combinations of the different kind of tools or software that is categorized as DevOps, which specifically participate in the automation of the complete end-to-end life cycle of your product from development till it goes to the production live environment, which is called the operations. So that means it emphasizes continuous integration, continuous delivery, and monitoring throughout the application lifecycle. So this is another important term that you will heard when you talk about the DevOps, which is CI and CD, which is called continuous integration and continuous delivery. Okay, so it's a very simple. There is no specific hard fast that you get confused on that. Okay, so continuous integration means that when you do the development of softwares, okay, so as I said, you have a multiple integrations in your softwares, right? And you have to make sure that each and every integration is working perfectly. And then when it is in combined, it is a single application. When you are expecting that your application should give a collaborated expected output by integrating all of the your solutions, okay, then it is called a continuous integration. Okay, and then continuous delivery. So that means you should have a proper integration testing in place, which ensure that all of the integration is working perfectly, and after that it is ensuring that you are getting a continuous delivery of your softwares with the features as expected and with the output which is as expected, right? So this is all about the same thing when we talk about DevOps and CI and CD, that what we are talking about is that we should have an automated process in place from development till operation. Okay, now I will give you one more example. So when we go for the setup of the environments, okay, then we have a different set of environments. We have a development environment, we have a quality environment, we have testing environment, then we have a pre-production environment, then we have production environment. Okay. Now traditional approach is that we have to install the softwares in each and every environment. Today you have a 10 developers. Today, tomorrow you will have a 15 developers. You have to set up the same set of machines, same set of softwares in all of the machines for the developers. And same scenario is for the testing and then some other environment as well. Right. And then when your different developers are working collaboratively on a single project, okay, so there we use the multiple version control tools as well, where all the developers work on the same project, maybe on a different modules, okay, and those modules has to be check in and check out to a central repository, okay, and then you have to combine all of the code that all the developers have been working, and then you have to ensure that every code and every module is working perfectly in collaboration by integrating with itself along with the external integration with the third party applications and other applications as well, right? And then the same code has to be moved from the different environments, from development to testing, from there to quality, then from pre-prod and then prod, right? So what we are doing, the same set of code that is getting moved between different departments, or you can say the different environments, right? And it has a lot of dependencies. Multiple times it happened that some of the software that has been tested in the development environment may not be working in the testing, or maybe it is working on testing, but it is not working on the pre-prod and the prod as well due to certain environment dependencies. There are a lot of dependent library files, and there are a lot of other different dependent stuff as well, with respect to the applications, right? So now, to avoid such situations and to save the complete time, where we are moving the complete code from one environment to other environments, where we are facing a lot of issues, for example, that one code is not working in development, no, it is not working in testing, okay? So to avoid such kind of issues, okay, we use the automation or the develop technologies, where we have a lot of components, and Kubernetes is one of them, okay, which is used in the DevOps for streamline, or you can say the automation of the process delivery from operations, from developments till your operations. Okay, so then we are going to talk about everything on with respect to DevOps along with the DevOps tools as well. Okay, and specifically what is the role of Kubernetes, how we implement that, and what are the benefits of that one, and then we'll go for the detailed explanation and detailed executions of lab as well with respect to the Kubernetes. So one important thing, Kubernetes is not a development tool. Instead, it is an orchestration tool used to manage containerized application or containers. Okay, so now this is another term, containers. You must have heard about that one, right? So we'll discuss about the containers as well. We'll have a exercise. We have sessions on the Docker containers as well, because container is one of the prerequisites for the Kubernetes. Why? We are going to cover in this session, and you will get it the complete understanding why we need the understanding or of the containers in the Kubernetes. Okay, the one thing is that it is not a development tool. Your Kubernetes is not a development tool. That means you don't need the development skills to learn the Kubernetes. Okay, without any development skills, you can be an expert in the Kubernetes. So it is just an orchestration tool. So that means it is doing a certain kind of a management of different set of softwares or the component. Okay, and what are those components? It is used to manage containerized application or containers. So it is doing the management of your containerized applications. So containerized application means those are running in the containers. Okay, so one thing is clear here. Your Kubernetes is a containerized tool, or you can say it is an orchestration tool, which is used for the management of containers, right? So we'll get a complete understanding of this in this session and few more sessions as well. Now, what are the prerequisites for becoming a Kubernetes expert? So when you are going to learn Kubernetes, there are certain things you should aware about that one. You don't need to be an expert on that, but yet you need a certain idea of that one. The first thing is understanding of Docker and containers. So not specifically Docker, because Docker is a containerized solution. Okay, you should have a knowledge of a containers, and with respect to the containers, you can have a knowledge on any kind of a containerized solution or the softwares. So Docker is one of the leading software for the containerized application. That's why I have mentioned here Docker. Okay, and most of the organizations are using the Docker as a containerized solution. Okay, so you should have understanding of the containers and the containerized softwares, for example, Docker. Then you should have some basic skills of the Linux. Okay, so you don't need to be an expert in Linux, but you need a certain kind of a small skills of for Linux, like you should have a knowledge of the Linux commands and some experience on that as well, right? And then you need some basic knowledge of the networking concepts, not at a very high level, but some basic concepts. Okay, and then cloud computing basics, because this Kubernetes can run on your on-prem servers. Along with that, mostly as of today, it is being utilized in the cloud. So that means we have a multiple cloud service providers. Okay, and they all are providing the Kubernetes services, which is called a managed Kubernetes services. And why we called it as a managed Kubernetes services, that we are going to cover in the next sessions as well. Okay, but now you can, as of now, you can understand, because this is completely managed by the cloud service provider. That means the complete infrastructure of Kubernetes is maintained and managed by the cloud service providers. Okay, so that is called the managed cloud Kubernetes services. Okay, so if you are going to execute or going to create the Kubernetes cluster in the cloud, then you should have some knowledge of the basic knowledge of the cloud computing as well. Okay, so these are the four different important prerequisites for to understand the Kubernetes. Okay, if we have the knowledge of that, that is good. If you do not have the knowledge, then don't worry on that. I am going to cover everything in this course. Okay, so whatever the basic requirement of all these skills that we will cover in this course. Okay, so let us begin with the introduction to Kubernetes. So now Kubernetes, also known as K8s, is an open source software or system for automating deployment, scaling, and management of containerized applications. First thing that Kubernetes is also known as K8s. Okay. Second, it is an open source system. So open source system that you can easily freely download anywhere on your systems, and you can use it without any restrictions or any kind of a licensing agreements or violations. Okay, because it is an open source system. Okay, but drawback is that when you are using the open source software, then you will not get a professional support from any organization. If you encountered any bug or any issues in your system, then you have to rely on the communities. You have to post your questions or queries in the communities, and then someone will reply on that one. Okay, you will not get a professional support, and that's why we always go with the most of the time we go with the cloud managed Kubernetes services. Okay, so this is a soft system or a tool for automating deployment, scaling, and management of containerized application. To what exactly this tool is doing? It is doing the deployment, scaling, and management of containerized application. So as I said, one of the basic prerequisites for understanding the Kubernetes is containers. What exactly is container? What are the containerized applications? Okay, because this Kubernetes is doing the deployment, scaling, and management of your containerized applications. Okay. So that will cover in detail. So container is a package of software that includes everything an application need to run, included code, dependencies, libraries, and runtime. So now what we discussed few times back, that we have multiple environments, and in every environment we do the same kind of a stuff, where like the installation of softwares in each and every environment, then the movement of your application from development to testing to quality, then pre-prod to prod. Okay, so this container, or you can say the containerized application, make this process efficient, okay, by packaging all the software and all the dependencies and code in a single package, which can be moved from one environment to other environment. So what will happen? You don't need to install your software. You don't need to pack and unpack your code every time you are going for a different environments. But you can create a single package of your applications, code, softwares, everything, dependencies in a single package, and that package can move from one environment to other environment. Okay, so that is called a container. So a container is a package of software that include everything an application need to run, include its code, dependencies, libraries, and runtime. So everything is bundled in a single package, which is moved between the different environments, which is called the container. Now, Docker is a software platform that allow you to build, test, and deploy applications quickly using containers. Okay, so Docker is one of the leading containerized solution, okay, in the market, okay, which is used along with the Kubernetes, right? So what Kubernetes is doing, as I said, it is doing the end-to-end management of your containerized applications. That means which is running inside the container. So if it is doing the management of containers, that means you need a container solution as well, right? And for that, we are going to use a Docker. So with the help of Docker, we can create the different containers, or you can say the containerized applications. And on top of that, you need the Kubernetes, which is doing the management of all of the containerized applications, which is running inside your container. So now as a base, you have a Docker where you have multiple containers. You have a multiple applications are running the inside the containers. So while Docker remains one of the most popular containerized solutions, several other container runtime and tools are frequently used as alternatives or complements to Docker. So as I said, Docker is not only the containerized solution, there are multiple solutions in the market. Okay, and but this is one of the leading and popular containerized solution. Some other containerized solutions are Container D, CRIO, Podman, LXC, LXD, Amazon ECS. Okay, and there are other many more containerized solutions are there from other cloud service providers as well as from some native softwares as well. Okay, and once you have a Docker containers in place, where you have a multiple containers, your multiple applications are running inside the containers, then you need a Kubernetes. Why you need a Kubernetes? For end-to-end management of all of the containers, because there could be a n number of containers in your environment. Okay, so it's not easy to maintain all these containers by switching or logging to each and every node or servers physically. Okay, so that you need an end-to-end management solution which should take care of the complete end-to-end management of your containers. When we talk about the management, it's not about only start stop of containers. There are multiple things that you need to take care when we talk about the management, so that we are going to discuss a lot in this course, right? So now Kubernetes and containers. So what we learned, two important things. The first thing is Kubernetes, what it does, and then containers. And so let me talk about the same definition again. So Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. So now we understood it properly. Kubernetes is known as K8s. It is an open source system software. And why we use it? It is used for the automating deployment, scaling, and management of containerized application. Okay. So now what exactly is a Kubernetes? It is an orchestration tool. That means it is doing the end-to-end management of your different containers. You can have n number of containers, and with the help of Kubernetes, you are doing the management of all the containers. Now let us talk about some different some features of your Kubernetes. Okay, I will try to explain in a basic way, and in next subsequent sessions we are going to cover it in detail along with the execution. So automated deployment and scaling. So Kubernetes can automatically deploy containers across cluster of servers, monitor the health of applications, and scale resources up or down. So what it does, as I said, you have a Kubernetes which is maintaining the multiple containers. For example, you have a 6 containers. Okay, tomorrow you may have a need of the multiple containers, few more containers. Why? We can compare it with a traditional environment. Okay, suppose you have an environment where you have a 4 physical servers, or maybe 4 virtual machines are running your web application. Okay, and that is where you configure the application with an anticipated number of users, 4,000. But in future, your business is growing, and your user base is getting increased, or maybe from 4,000, tomorrow it is a 4, 5,000, 6,000, or 7,000 users. So you need to scale your environment. So when you are in a traditional environment, you have to do a complete planning again. You have to buy the physical servers, or or maybe you have to provision the new virtual machines. Then you have to do the installation of softwares. Then you have to deploy your code applications. Okay, so that your environment gets scale, which is in a traditional. When we talk about Kubernetes, where you have a requirement, that same requirement. Okay, what happened is that instead of this kind of a manual stuff, what you can do, you can scale your environment and increase the number of containers according to your requirements. So today you have a 6 containers, and tomorrow you may need 2 more containers. So it will take fraction of seconds in the Kubernetes to scale your environment v4 with few more containers. Okay, it will save a lot of your efforts. Okay, and maybe tomorrow you need a less number of containers. You may have a less load in your environment, so you can easily scale down your environment as well. So this specifically used when we have a certain kind of applications where we need know that there could be a high load in our applications, maybe in a certain day of time or a duration. Okay, for example, 10 days in a month we have a high load, but 20 days we have a stable environment where we have a less load. So we can scale our environment to the maximum capacity on that 10 days when we are expecting a high load in the system, and for rest of the 10 days, 30 days, or 20 days, we can reduce the number of containers to save our infrastructure and other cost. Okay, and all these things you can do with the Kubernetes within a fraction of seconds or a minutes of time. Okay, without investing any of your manual efforts. Now, load balancing and services. So we know what is load balancing, that we have a multiple application servers or web servers, and when the requests come to your applications, it is distributed properly between your all the servers which is running the applications. Similarly, in the Kubernetes as well, when you have a multiple containers, okay, then if the requests are coming, or your application requests are coming, this Kubernetes can distribute the load between different containers. Okay, for example, if the first request will go to the first container, second will go to second container, third request will go to third, similarly subsequent will go to 4, 5, and 6, and if you have a total 6 number of containers, the seventh request will again route to container 1. So that means your Kubernetes support the load balancing of your applications as well. Another important feature of Kubernetes is the self-healing. That means it automatically check the health of your containers. Okay, and if any of the containers is not healthy or not responding or get crash, okay, then it automatically detect that, and instead of that it automatically bring up the other container. Okay, in that case your applications will not get overloaded. Okay, for example, if you need the 6 number of containers, and if any 1 or 2 containers get crashed, then other containers can be overloaded with the request. Okay, so this Kubernetes ensure that your all the number of expected number of containers are up and running, and if any container is not responding, then it will automatically initiate the other container instead of that. This is called the self-healing in the Kubernetes. Now it can does the automated rollout and rollbacks. That means when we deploying new versions of an application, Kubernetes can gradually replace containers while monitoring their health, ensuring that changes don't disrupt the overall applications. Rollback to previous states are also easy if issues are detected. That means what we do in a traditional environment when we have a new version of application that is getting released, so we have to remove the current version from the current production environment, and then we have to deploy the new version of our applications in the environment. Okay, so now with the help of Kubernetes, we can do the automation of that one. Okay, in fact, you can do the rollback of the automation of the rollback as well. If in case you need to roll back to the previous version, then everything is taken care by the Kubernetes without any manual intervention. Okay, so that means, for example, today you have a 6 containers with the application of version 1 as of now, and you would like to release a version 2 of the application, then it can gradually replace your containers with the new versions. Okay, maybe the container first, then second container, then third container, then fourth, fifth, and sixth. Okay, it can gradually apply the new version in your containers gradually. Okay, and suppose you would like to roll back to again to your version 1.0 due to any reasons you have some problem with the new deployed application, then you can roll back to the previous version easily. Okay, with the help of Kubernetes. Now you have a feature called storage orchestration. So Kubernetes allow you to mount storage systems to containers, providing durable storage for applications. Okay, so multiple times it has happened that we need a certain kind of a shared file systems in our applications. Okay, which where certain number such kind of files that need to be shared across the multiple servers or virtual machines in the traditional environment. Similarly, if we have multiple containers, and you may need a certain set of applications, or you need certain set of files that need to be shared between all the containers. Okay, for that we have a storage orchestration as well, where you can mount your system directory, okay, which is as a shared directory to all of the containers. Okay, so in that case, all the containers can have access to the shared directory. Right. So now what we have learned, we needed a containerized solution. Here we are going to use the Docker. Docker, on top of Docker, we will create the multiple containers, and then Kubernetes will do the orchestration or management of all the containers, and user can interact with the Kubernetes, and with the help of that they can do the end-to-end management of the containerized applications. Okay, so now there could be multiple applications. Okay, so that means your Docker and containers may run on the multiple machines, which is called the horizontal scaling. Okay, and for example, you can see in this figure you have 4 machines. In each machine you are running the Docker, and your Dockers are running the containerized applications, and Kubernetes is doing the administration of all the containerized applications which is running across all of the machines. Okay, and specifically when we talk about the Kubernetes, then the combination of containers are called pod. Okay, this is very basic terms in the Kubernetes which is called pod. So pod is a grouping of containers. Okay, so there could be n number of containers, there could be n number of pod. It depends on the kind of resources, hardware resources that you have in your system, in your physical machine, or maybe in your virtual machines. Based on that, you can create n number of pods in the Kubernetes, and inside each pod you can have a n number of containers. Okay, so the two terms that is very important in Kubernetes that you have to understand, one is the master node and second is the worker node. Let me go back to previous figure. So here you can see that we have a multiple machines where our different pod and containers are running. That means our applications are running inside the pods, inside the containers, right? So we have a Kubernetes, which is doing the management of different machines where our Docker and containers are running inside the pod. Okay, so now let us take a look here. So all the pods and containers are running in the worker nodes, and the node which is doing the complete end-to-end management of your worker nodes, where our Docker and maybe some other containerized solution running with the containers and pods and applications. So this master node is doing the end-to-end management of all of the worker nodes. Okay, for example, if you would like to roll out a new application or new version of your application, then it can be initiated from the master node, and it will automatically look for all the worker nodes are associated with the application, and it will automatically deploy the new version of your application in all of the worker nodes, right? So this master node is called the control plane in Kubernetes. It can be referred as master node or control plane, anything, right? And where the pod and applications are running, it is referred as worker node, and this master node is doing the end-to-end management of your worker node. So what we have in the worker node, we have different pods in the worker node, and inside the pod we have a containers, right, where applications are running, and your master node or control plane is doing the end-to-end management of your worker node. So this worker node and the master node, they are running on the different machines for the high availabilities, right? So if your master node is controlling your worker nodes on the different machines, okay, so to work in a collaboration way, you need a certain set of component or software components, okay, which allow your master node to interact with the worker node. Similarly, you need a certain kind of a component which should allow the communication between the worker node and master node, right? So for that, we have a different kind of a software component inside the Kubernetes. So that means when we install the Kubernetes, when we set up the Kubernetes environment, it installs the multiple components, some of the components in the master nodes and some of the components in the worker node, which allow the communication between master and worker node for end-to-end management of the containerized applications. And we are going to talk about all these things. What are the different components in master? What are the different components in worker node? How they work efficiently in the collaboration, and then we'll talk about in detail about the architecture of the Kubernetes, and then we'll move forward to understand the other basic and high level of concept of Kubernetes along with the execution of the lab exercise. Thank you.